Hello and welcome to this LiveMath explainer video. My name is Will, and today I'm going to be taking you through the controls of a 2D graph. Now this is not what you put into the graph. This is the controls that let you look at it in different ways. So I'm going to need a graph here, but since I'm not actually um, plotting anything, I'm going to do it this way. I'm just going to insert a 2D graphics primitive. So it gives me a graph here. There's no graph being drawn. You do see the grids and the axes, but that's it. The things I want to focus on here are all the different buttons that you can click on and what that does for the graph. So we'll start first of all with this one up here, the upper left corner. Clicking on it selects the whole graph. Once the graph is selected, if you want to move it around, you can hold down the control key and then click on it, and this allows you to move it to different places. You can place it there anyway. um, Stuff in LiveMath, as you may know, can be moved around by selecting. This is the selection button in the upper left corner. In the lower right corner, the opposite corner, is the resizing button, where you can click and drag to resize. You may notice that there's numbers there which show you the size, both the horizontal and vertical size, in points, inches, and millimeters. So take your pick as to which one you want to look at and make the graph the size you want it. Okay. Now, these buttons. I'm going to start not on the top one, but on the second one, this rocket ship. This is the zoom out button. This is the one I think I use the most. If I just click it, it essentially doubles, well, both doubles the length and doubles the width that I can see. So I guess that's 4 times the area. Do it again, it doubles it again. If I hold down the Alt key, now I'm on a Windows machine, so if you're on a Mac, it's probably the Command key, and you click the, the rocket ship. Well, this is now zooming in. So I use the rocket ship both to zoom out and to zoom in. The knife is designed for precise zooming in. That is, if I click on this knife, it looks like an X-Acto knife here, I can drag a rectangle. And typically I go from the upper left corner to the lower right corner. And it takes that rectangle and stretches it out to be what's viewed then. You can do any opposite corner to opposite corner. It doesn't have to be upper right to lower left. You can do it in a downward direction. You can do it in an upward direction. It doesn't matter. As long as you're getting opposite corners of a rectangle, it then expands that rectangle to be the viewing window here. Now, if you know you're going to be doing a lot of zooming for some reason, you can double click that. Then it stays, it actually looks like a little dagger now. It's the same process, but you don't have to go back and re-click it every time. It's just already there. Okay. Now I'm gonna zoom back out, because the next thing I want to do is talk about these grid density ones. And so I actually need a, oh, I forgot to mention, if I click this again, that shuts it off. I'm going to put a graph in here just because I need it. I got y equals sine x, and quickly just grab that, drag it in, draw the graph of it. Yes, please. X is independent, y is dependent. Okay, and you zoom out. Let me get a window that I like here. Let's kind of go from here to there. Good. These don't do a lot on a curve like this, but they do something, and I want you to see what it is. And each time I click it, you can see like that says 4 to 2, 2 to 1. It's decreasing. This one down here was decreasing the number of points that are being used to draw this graph. And I go all the way down to 1, and it's like it's not plotting very many points and then just drawing straight lines in between them. If I up the density, so 1 to 2, 2 to 4, 4 to 8, you can see it smoothing the graph out because it's plotting more and more points. Okay, not as important on these 2D graphs. On a 3D graph, these are very important for being able to graph surfaces. And there are some surface plots that you can do in 2D graphs, essentially region plots, and in that case, the grid density is definitely useful. Now, one last button here on the outside of the graph, and that allows you to see the inside of what's going on. This is the details button, and it opens up a box underneath. And so there's two parts to this. One is what I want to look at in this video, and one is what we'll look at in a subsequent video. This is the stuff that goes into the graph. This is the stuff that's still helping you look at the graph. So first thing I want to look at these two drop-down menus. This one has two options on it, stretch to fit or true proportions. The default when the graph comes up is stretch to fit. If you switch to true proportions, then it's showing 1 unit in the x direction is equal to 1 unit in the y direction. So you get to see the real shape of the graph and not stretched out. Sometimes it's funny if you draw a circle and it looks like an ellipse because it's being stretched, or you draw an ellipse and it looks like a circle because it's being stretched or shrunk, whatever. Okay, true proportions let you see the real shape of the graph. Then there's this one, the cropping. The cropping is essentially how much white space is put around. Let me go back to stretch to fit. So we're filling up most of that rectangle. If I crop this very widely, then it puts a lot of white space around. If I crop it very tightly, you've zoomed. You haven't really zoomed in, but I guess you kind of zoomed in. And it actually, that's so far I can't even see the axes. But you have your choice of, depending on what you're doing, you may want more or less cropping. Okay, so you have those options. Now we get to this bit over here, negative 3.4 ... 3.8 equals left to right, and negative 3.6 ... 3.8 equals top to bottom. These are the bounds of the graph. The leftmost x value is negative 3.4. The rightmost x value is 3.8. Right now, and likewise top and bottom here. If I were to use the rocket ship here, you can see that it changes those numbers because now we're viewing a bigger rectangle and those numbers change. Using the knife as well will change those numbers. What I really like about this is that, yes, the tools affect those numbers, but I can affect those numbers. If I want to look, it's like I know I want to look at negative 3. Oops, let's type this in again here. If I want to look at negative 3 to 3, I can type that in. Now, I inadvertently deleted too much, so I just typed the whole thing in again. In fact, I'll do it again here. If I had this whole thing selected and I inadvertently do that, it's like, wait, I want negative 3, and I'm doing a ... and the ... LiveMath knows, oh, you were trying to describe a range of numbers, and so then it sets me up to put that other number in. And so now I've got negative 3 to 3, both up and down and left and right. Now, LiveMath is actually assigning these values to the variables. So left is negative 3, right is positive 3. And down in the creation of the graph, the stuff that's going in, you can use those left, right, top, and bottom. For instance, this curve plot is plotting for x values between left and right. So you see that graph all the way across. In another explainer video about curve plots, we'll show how you can change these numbers and why you might want to. But for now, just know that left, right, top, and bottom are the x min-max and the y min-max that you're seeing in this graph. You can change them manually or with the zoom tools. Okay. So anyway, there's an overview of the controls on a graph that allow you to look at it in different ways.